Hello and welcome to Differential Equations. I hope you guys had a great lazy weekend, and I mean Labor Day weekend. Same thing. No one worked Monday, right? The goal for today is to talk about 1.2, which is the section on solutions to differential equations. The integrals as the solutions. Yeah, the job is to learn the way to check again differential equation. We talked about it a little bit last time, and then see the difference between the general and a particular solution for the differential equation. So last time we reviewed a little bit from Calc 2. We reviewed a little bit about the solution, what it's called, solution. My brain just went out, like it said bye and left me. Separation of variables. There we go. Yes. So last time we talked about separation of variables. There's going to be a full lecture on separation of variables next class on Monday. We're going to talk about the method in depth, even though you have seen it in Calc 2, you've seen it last class, and you're going to see it again now because it's the cheapest one we have. Let's talk about the solution. So last time we said the differential equation is the equation that contains independent variable, function, and its derivatives. And as it goes for equations, the way to solve an equation practically of any type is to use the opposite operation. So logarithmic equations would use exponential functions or exponents. Derivative equations, which are differential equations, would use integrals, right? So if you have an equation that we had last time, like the change of population in time is proportional to the population, we separated those variables, k dt, and then we integrated both sides. Because you want to undo the derivative. These differentials, dp and dt, you can undo those by integrating both sides. On the left-hand side, we said that we are going to get the ln of absolute p, and on the right-hand side, we had kt plus c. And that eventually gave us the form of population in time equals to initial population e to the kt, and we talked about it as the model and all of that stuff. Now I want to go back and make sure that we are looking at, so let me see. Oh, hold on, there's a question in chat. All right, so we use the integral, right? We use the integral to undo differential equation. And once we undid the derivatives, right, we got the solution. Now, something like this will be called the general solution. And the reason why it's called the general solution is because this constant c is still unknown. That constant c became p0. We know conceptually, for this particular word problem of population, we know conceptually that p0 is initial population. But remember how last time I said we put 200 or 500 rabbits, whatever I said, right? Well, that means that in that particular case, we know, right? We know the amount that we're starting with. And that would be particular solution because we know. But when you don't know, right, you call it general solution. Now let me explain this again using much easier function, and then we're going to understand where it all goes from. So let's go with the differential equation dy dx is equal to x. That's it. We know we're supposed to separate variables, so we're just going to ship this dx to the right. So dy is equal to x dx. And then we're going to hit both sides with the integral sign. And we have our solution of y is equal to x squared over 2 plus c. I could have started this as 2x and then we won't have this fraction. Yeah, let's do that. Let's just say 2x and then 2x and then we don't have, it's just x squared now. Much better. There we go. Switch that. All right, so we start with a differential equation. It is a linear equation. It is first order because it's just the first derivative, right? Independent variable is x. Dependent variable function is y. And we use separation of variables to solve it, where we put all of the variables of one kind on one side and all of the variables of the other kind on the other side. And we get the solution of y equal x squared plus c. Now, this solution here is called general solution. And the reason why it's called general is because this c is unknown. Same as the previous example. Now, what does that mean for the graphs? That means that you are going to have infinitely many of these parabolas at every value of c, infinitely many of them going through this. They're all stacked. Because this c, in this case, shifts function up and down. Depending on its value. So this general solution actually has infinitely many curves. They're all of the same shape, x squared. They're all the same shape, which is x squared. But then there's infinitely many of them. So no particular curve is picked. And that's why this is called the general solution. But then what we have is particular solution. And to get that particular solution, you need additional piece of information given to you when the equation is given to you. So if I am to repeat the problem, dy dx is equal to 2x, and I provide you with additional piece of information which says y of 2 is equal to 9. This extra piece its point actually allows us to compute C. So when you get a problem which has this initial point, boundary point, initial condition. There's a lot of different names for it. When you have this extra point given, then you are able to compute. So now we know that this solution over here is y equals x squared plus c. Come on. X squared plus c. There we go. It looks like this is getting, yeah, I'll have to get the cooling pack. And now what we are going to do is we are going to plug in this value and you will be able to compute c. You see that when you plug in x equals to 2 and y equals to 9, the only variable that you, well, I mean, the only, it's a constant c. The only thing you can compute there would be the constant c. So y equals 9 is 2 squared plus c. 9 equals 4 plus c. C equals 5. So having this extra point allows us to compute the value, and now your solution is y equals x squared plus 5. This type of an answer is called particular solution. And it's called particular solution because this is just one out of those infinitely many curves. It's the one that goes through y equals 5 because it's just x squared, right? X squared goes through 0, 0, and then you raise that 5 units up. So now, if you draw x and y axis, you will draw, there we go, through 5, and let's say over here somewhere is 2. And if you go all the way up over here, this is going to be your 2, 9. It has to go through the point that you picked. So that's going to be your 2, 9 value. So that's the difference between the general solution and the particular solution. Particular solution will have exactly one curve because you calculate the value of c using the extra point that it's given to you. And now we can go back to your pre-calculus problems, which you solved many moons ago. You had population problems, you had mass decay problems where you computed either radioactive decay or garbage decay or those C14 isotope for carbon dating. Those are all decay problems. And then you had the population and maybe money and so on for exponential growth. All of those problems are different variation of the population problem we did before because they all have this equation P of t equals P0 and so on. Just if you want the mass decay, you put M and M for mass. If you want the population, if you want money, you use A and P for amount and principal, right? Money borrowed or money you owe and so on. So that's the trick. Now let's go and take a look at the pre-calculus problem because actually we are not learning differential equations today. We're learning the solution of the differential equation, which is actually what you did in pre-calc problem. So they tell you that you go to some habitat, so some desert island, there is nothing there other than grass and cabbage, and you airdrop with parachutes 500 rabbits, right? So you can say that you have your population formula, which you got from differential equation. I gotta get the cooling, give me a second. All right, we'll be there 1 second. Just put a cooling pad under. This is my second class, so the tablet has been on for like almost 4 hours now, and it reached the point when it's overheating, so I have to use cooling pads to keep it cool so we can get through the class. All right, so P of t equals P0 e to the kt. This is our equation for population. And as I said, we airdrop 500 rabbits, or whatever, but the rabbits is easier. So 500 rabbits are dropped in, and after 1 year, number grows to, let's say, I don't know, 1,700 rabbits. When you have this much information, the best way to do, obviously, to solve the problem and go about it is to categorize all of this into points first, understand which way, right? So this is all also the part of modeling and, still going back to the first lecture and so on. So my points will be time, comma, number of rabbits. So my first point is, remember, desert island, there is nothing on it, and then we airdrop 500 rabbits. So time is 0. This is where the rabbit life on the island begins. So that's why time is 0. And we have 500 units, right? Now, clearly, we dropped in male and female, so they can reproduce. Otherwise, if you drop just a male or just female, they would not reproduce. And by the end of the year, some of them might die, right? Gladiator fights and whatever they do. You would have less than 500. But if you drop male and female rabbits, they will do what rabbits do best. They multiply, and they multiply a lot if they don't have any predators to keep their numbers down, and they will destroy all of the vegetation. Rabbits are actually very, very bad animals. Now, you might have them as pets, but yeah. Luckily, we have snakes, we have fox, we have a lot of other animals to keep that population down. Otherwise, it would overrun and eat literally everything. There would be no plants. Now, you wait a year. That's how the time becomes 1. And then there is 1,700. Why is it 1700? Again, no predators. It was a desert island. It's just grass, cabbage, and now rabbits. So the population grows. Now, I don't know if in 1 year it will be 1700 or 3 million. It's just, I need a number bigger than 500, right? So, whatever. Using the first point, we know that that's initial point because time is 0. As soon as time is 0, P0 is 500. You see that? That's the initial case, initial point. So we have a 500 initial population of these rabbits. So now I can write my equation as P of t is equal to 500e to the kt. Now, if you take a look at this equation, it is still not particular solution because k is unknown. You are only allowed to have your independent variable t unknown, so you can use it as the equation. You need to know your k. Plus, k is going to be the k for rabbits, because humans don't multiply this quickly, right? I mean, in terms of it takes 9 months to cook up a baby, plus, right? Twins or triplets, it's rare, right? It's rare. I know that they can be, 4, 5, 6, and so on, but that's really, really extremely rare, where the rabbits have the litter, right, of number of rabbits every time. So clearly, this k takes in the account of how quickly the species would multiply, and that would be reflected in that number. And we need this second point to calculate k, because look what the second point gives you. Second point gives you the time and gives you the population. So when you plug those two in, you will be able to compute k, and that would be the k for this rate of increase in population. So now we're going to say 1700 is equal to 500 e to the k, right? Because t is, well, I'll put t is 1. There we go. So now you would divide 500 into 1700. So that's going to be 17 over 5 equals to, leave some space, e to the k. And then you will ln both sides to kill off e. And there's your k. K is ln of 17 over 5. If you are computing this to the decimals, make sure you close the parenthesis after 17. Otherwise, it will do ln 17 everything divided by 5, and it's going to give you wrong number. So you push ln on your calculator, then you do 17 divided by 5, and then close parenthesis. Oh, I said it wrong, right, didn't I? Okay, go back in a YouTube video and just confirm that I said it wrong. Do not close the parenthesis after 17. Whatever, use the calculator properly. 1.22 4, whatever. Well, you should have 4 decimals for, so 38. There we go. All right. So now I have my k, and when I write this p equals, or p of t, right, it's a function of time, 500 e to the 1.2238 t. This becomes particular solution. And this number 1.2238 is the rate at which the rabbits are multiplying. And it's particular because it's particularly for rabbits. Humans are going to have much smaller number here because, as I said, we don't have a litter, right, of 8 or 9 every time, right? There is baby coming up. So when you are solving these problems, you will have the general solution right here. And then you might have to write the general solution, and then you might have to compute the points in it to come up with a particular solution. Now, let's say you care and you want to check if the problem that you, like the function you have, is correct. Well, there's nothing you can do for the actual values of 500 and 1.2238. You would have to just recompute everything and make sure everything was good. But you want to check if this actually solves the differential equation which said that the population, right, is proportional. So remember what your differential equation was. This is the check, which is why it's blue. dp over dt was kp. And you also calculated that k is 1.2238. Right? So that was it. So you can call this differential equation p prime is equal to 1.2238p. And you want to check in here. Check here. Now, what do you have? You have the p, because that's 500e 1.2238t, and you need to find p prime, because you need to plug in p prime on the left side, and you have to plug p on the right side. So p prime is, you copy the constant, then the chain rule kicks 1.2238 down, and e to the 1.2238t stays the same. And now you plug them in. So the p prime side says 500 times 1.22. You can compute this if you want to. 1.2238 equals to 1.2238 times p, which was 500e 1.2238t. They're the same, even without computing. I did change the title. I see you guys are saying title is, I did change the title in the YouTube changed to this stupid new system they have, and it's not remembering the title change. I don't know why. Oh, when I click save. I didn't have to do that before. Okay, fine, whatever. I will change this when I upload this to YouTube. I will go in and change the title manually, and then hopefully I will remember next time to press. Oh, it actually changed? Not made for kids. Yeah, it's not made for kids because you know me. I mean, some of you know me. All right. What else should we do? They also discuss the velocity in this one, which is, I believe, another one that I talked about last time. When you have a parabolic motion, now that one would have two constants to compute. So this is technically going to be Calc 1 problem, and then Calc 2 problem, and then it's going to become differential equations. So, projectile motion. We're going to start with the gravity given as, the acceleration given as gravity. Now, acceleration is change of velocity in time. And I think I mentioned this last time. You're driving, right? You have your gas pedal, which increases velocity, and you have the brake, which decreases velocity. So both of those pedals are actually acceleration pedals. It's just one is positive, one is negative. I'm going to plug dv dt over here, equal to negative g, which is a constant, whether you want to do metric or imperial system. And now we'll do the separation of variables again. And you, after integrating, you are getting the first general solution. So velocity is going to be negative gt plus v0. That was your C from before. So this is the general solution. Now, how do you get this to be a particular solution? Well, you tell me what the initial velocity was. When you are parked at the, stopped at the red light or a stop sign, the velocity of your car relative to its surroundings should be 0. You are stopped. So V0 would be 0, and that's your initial velocity. Then you push the gas pedal, and acceleration will change velocity from 0 to whatever you will be going to. To the speed that you will be going at. Now, you can hear the word change, and that's why we say that change in velocity is called acceleration. Now, what we can do is we can call velocity change in position in time. So velocity equals ds over dt. S is the position function. It's clear that we're going to use S, right? Because it's in the word. We use separation of variables again, which is ds equals negative gt plus v0 in parentheses everything times dt. And then we hit both sides with the integral. And you get your position function S as negative 1/2 gt squared plus v0t plus s0. Now for projectile motion, we use y because it's height. So for projectile motion, we use y, height. So we're going to put this, and we're also going to say general solution, because I have these two that are unknown. Now I want you to think about throwing, let's say, a baseball or a snowball or a grenade, whatever, right? There you go. It lands right there, some position x away, and it's going to have this y max position. And it's all also happens in time. So I can have another graph that goes like this, woo, and then that's time, and that's also y for the height. This is a y max. And you throw from here, and it lands there. So what do you have? If you focus on these graphs, first of all, you see the downward opening parabola. Now, if you focus on the right one, because that's the graph for it, do we all see negative t squared? Well, you better, right? Because negative t squared is negative x squared, which opens downwards. Now, tossing an object, it's not the same for me and let's say my son, who's much shorter than me. It will impact the distance, because if I am to toss from this height with the same initial velocity, it will look like this and it will fall further. So that's how your S0 or Y0 impacts the motion. The taller you are, what you throw will go further, right? What the basketball players, right? They're all 17 feet tall. So the height is important in the projectile motion. Also the angle and so on, but that will be given by what we call initial vector, right? Now that initial vector will have a component v0, which is initial speed, which is the feature of our equation. So when you start thinking about physics equations, and I said start thinking, not using them. Using physics equation, copying it from the paper to the test is monkey sees, monkey do. It's a waste of time and it's a meaningless thing. If you are using a paper with formulas on the physics test, you don't know physics, you will never know physics, you will never be able to use physics. And that's the end of the story. There is no debate in this statement. You know nothing if you don't know the formulas, because you never stop to think about the formula. Looking at the screen right there, you see the features that if you stop and think for 30 seconds, you say, well, this formula can't be anything else but this. Anything I throw, which has physical existence, which has mass, will be affected by gravity to fall down on the surface. So I have to have gravity in the equation. And I do. Anything that I throw, when I throw it, I propel it with my hand, which means that it has initial velocity. That's a v0 part. And if I throw it harder, it will go faster because I put in more initial velocity in it. And if I throw it slower, it will go slow. And if I just drop it, it starts with initial a velocity of 0, so it's just a drop and just hits the ground. And it doesn't make any forward motion because it's dropped, so just a vertical drop down. And I already talked about the height, the S0. It also depends on how tall you are. You want tall basketball players, right? Because those hoops are high up, right? So you want them to be tall so they can use less strength and less force and less effort to shoot 3 points off of the line, right? Than someone who is, let's say 5'5", trying to make the same hoop. Way more energy needed because there is longer path to cover, right? And you have to go into parabolic motion because everything you throw without any kind of internal thrusters, meaning propellers, rocket, whatever, will go into parabolic motion and fall, given restrictions on air drag and all of these kind of things but that can be computed as well. So we have the general solution now, which has two of these parameters, V0 and S0, which are crucial for our motion here and for our equation here. So that takes care of that, and those are the things that you can measure, right? So if someone is throwing a baseball, you can use one of those radar detectors, right, to figure out the initial speed, and you can measure initial height easily, right? Because all the person has some kind of backdrop with a measuring grid on it, and you would have those two numbers. Once you have those two numbers, this solution becomes particular solution because it pertains to the situation you're in. This is the person's height. This is the height from which he tossed the ball. This is how fast the ball started moving. Gravity is a constant, right? Whether you want to use imperial or metric, and you have the particular solution. So you will have these two to consider. And remember, you need initial points in order to compute these things. Now, if they ask you for maximum height happens, I'm just going to kill this, maximum height happens here, right? That's the Y max. So both of these, right? So that's a Y max. And the way to find maximum height is to actually use the velocity formula, because vertical velocity is 0 when the maximum height is obtained. Think about it. If you toss balls straight up in the air, it will go up, but it will keep slowing down because the gravity is pulling the other way. It's not actually pulling, but whatever. So you toss the ball up, it will get to its max height, it will stop, and then change the direction and start going down. So at the maximum height, you have 0 upwards velocity. So let's put Y max. We have V up equal to 0. So you can use the equation V0 equals negative GT, no, V equals, right? And that's technically your V up, equals V0. So if you have initial velocity, which is how strong you toss the ball, how fast, and negative GT, this equals 0 when Y equals max. So you can calculate time. So you get time, then plug time t into Y, or S, we use the S of t equation. And this is how you do physics. You start with a concept that it's words. Population, the change in population is proportional to population. For physics, right? You will say the change in velocity in time is equal to acceleration. And then you develop the formula, and when you are done with the formula, you can check dimensions, make sure everything is correct, and also stop for 30 seconds. You will never need the paper with formulas ever again if you learn the way to think through differential equations, which is what gave rise to all of these things, right? A lot of parts, you know, F equals ma. You probably see me walking with a shirt. F equals m dv dt with vectors like this. I actually have this t-shirt walking. Sometimes I use it. And this is Newton's second law of motion, which says that the force acting on the object, right, is directed in the same line where the motion is. You learn this in a non-vector form as F equals ma, but this is actually the form that you use, and this is differential equation. I hope you all see that velocity v dv dt in there, right, which is acceleration. So that's still a differential equation which you can consider and learn. So it's a constant, right? And you can go and solve this differential equation and come up with eventually come up with more formulas that you can use. So all of differential equations, now this is tying in the first lecture and modeling and what we did now. Differential equations are developed by observing the nature. You come up with a sentence that makes sense with your observation of the nature, and then you write it as a differential equation, and then you use some of the methods that we are going to learn. You know, one of the methods we're going to learn through the entire course to solve that differential equation and get that formula at the end. So no one invented formulas, right? If you ever sat in a physics class and thought, oh, who comes up with this crap? Who thought of this? No one thought of that. They observed the physical phenomenon, wrote the differential equation, and solved the differential equation to get the formula that you copy on a paper and just use to compute meaningless numbers, right? The only thing that is important here actually is the concept of physics, the beauty of physics, the beauty of observation and experiment that you do, and then writing that observation as mathematical statement, which is differential equation, and then solving the differential equation to get the formula which you can use to compute different values and different states of the physical system. And that ends 1.2, right? They ask you to solve a whole bunch of these problems just to check if you are able to integrate basic or a little bit more advanced integrals, right, depending on whether the integral is in Calc 1 or Calc 2. And use the point to calculate the unknown value c. So let's take a look at two examples from the textbook. One of the examples says here, dy, problem 6, dy dx is equal to, this falls in x times x squared plus 9, and y of negative 4 is 0. So it's a first order equation. They gave us one initial condition. That's great. And we can go from this. Now, this falls in the category of what I call nonsense problems, because it's just practicing the brute force of computing things without giving it any meaning. The best problems, obviously, are the physics problems, engineering problems, biology problems, things where you can observe the system, make the differential equation that has purpose and utility, and then solve it. This garbage here is just, hey, look, I can integrate. That's it. So we're going to use separation of variables again, and now we just have to figure out how to integrate this. Would anyone drop in chat what would be the way to integrate right-hand side? To help me out a little bit, I've been only doing this for 20 years, so it's a struggle. Excellent. This is a basic U sub problem. Can you make it worse and do the trig sub? Of course. Would you get the same answer? Of course. You can do trig sub on this. U sub is the best answer. So your process of integrating in this class should be mainstream this way. Is this a basic integral? Can I just do it without thinking? Meaning, integral of sine is negative cosine, integral of x squared is x cubed over 3. So if it's a basic integral that it's in the table in Calc 1, woohoo. The next question after that is immediately, can I do U sub? I don't care if it looks like trig sub can be used, integration by parts could be used. Doesn't matter what the problem looks like. Is it possible to do the U sub? Because that's the next most frequent, most powerful, and most used technique. Always ask yourself first, can I use U sub, which is 5.5 in your Calc 1? If the answer is no, then whatever witchcraft works in terms of the Calc 2 methods. But you always check U sub first. Now, for our U sub here, we have U equals x squared plus 9, du equals 2x dx. Now I need that 2, so I'm going to fix that. There we go. And y equals, and by the way, those of you answering U sub right in chat, that's good job, right? 1/2 integral of root u du. So the mess under the square root became just u, because we defined it as u in a substitution on the right. And 2x dx together becomes du. So now we integrate this. That's 1/2 u to the 3/2 divided by 3/2 plus c. And I already told you that once you forget plus c in differential equation, you're done. You're just that's it. Everything went to hell immediately in that instant, right? So make sure you always have your c plus c present. And I have my y equals, the 2 and 2 will cancel. So it's 1/3 u is x squared plus 9 to the 3/2 plus c. I am going to box this, even though I'm not done, because I want to give it its name, right? General solution. But we were given y of -4 is 0, which means x is -4, y is equal to 0, and we plug those in to calculate c, which will give us particular solution. So y is 0. Then we have 1/3. Then we have negative 4 squared plus 9. Then we have 3/2, and then we have plus c. So 0 is equal to 1/3. Over here I have 16 plus 9. That's 25 to the 3/2 plus c. And the half is a square root. So we get 125 over 3 plus c. Again, square root of 25 is 5. 5 cubed is 125. The negative sign died because negative times negative is positive. So this is all we have. And from here, c equals negative 125 over 3. So now I actually have my particular solution, which is 1/3 x squared plus 9 to the 3/2 minus 125 over 3. This one is called particular solution. And this is what they are looking for as the answer once you have the point given. Now, my MATLAB, being that it's new, this is its first year. It started this January, so it's still in version 1. They might have glitches with answers and so on. If I was answering this in my MATLAB and I put this in and it tells me it's wrong, the next thing that I would try is to factor out 1/3. So I would also try, I'm going to erase this, 1/3 of x squared plus 9 to the 3/2 minus 125. I would also try this answer. And then if it doesn't take that answer either, well, I might mess something up. Now, what do I have here? I have a solution. All I need to do is to plug that in here and see if it works, right? It better work. So there's that, right? When you differentiate this. Now, when you differentiate this part dies, and it's much easier to solve the problem. So cool. That's that. They also give you a couple of problems, 11 through 18, with velocity, acceleration, and all that stuff. And I can pretty much guarantee you're going to see some of those for homework as well on my MATLAB. And let's see. Ooh, nice. Problem 18 has acceleration given as 50 sine 5t. V0 given as, oh, there's a baby spider over here. Get lost. There we go. V0 is negative 10 and x0 is 8. Let's go. Acceleration is change in velocity over change in time. Separation of variables will kick dt to the other side. So I will have everything in parentheses, 50 sine 5t. And we're going to integrate both sides. And we get our velocity is this thing here, which is the derivative of sine is cosine. The 5 jumps out, so 250 cosine 5t plus c. Now, I have that velocity at time 0 is negative 10, right? Plug in. So negative 10 velocity is 250 cosine of 0 plus c. Now cosine of 0 is 1, and then 250 going to the other side becomes negative 260 equals c. So now we have that our function v of t is equal to 250 cosine 5t minus 260. And we can find the x, which is the position, by writing velocity as change in position in time, right? Because if you're sitting still in the spot, you're not getting anywhere. If you are moving at the velocity v from point A to point B, you are covering the distance, you are changing your position. So that's why velocity changes position. And we have our 250 cosine 5t minus 260. So we do separation of variables, where dx is equal to 250 cosine 5t minus 260 dt. Hit both sides with the integral sign, and we get x equals 250 cosine 5t minus 260. All of that, well, no, I need to integrate. Go back. When I integrate, wait. No one said anything. This is all wrong. I was just testing you. Supposed to integrate, not differentiate. This is the derivative. Integral of sine is negative cosine, so this becomes negative 10 cosine 5t plus c. Because the integral of sine of 5t is negative cosine 5t over 5 plus c. So we have negative 10, because 50 divided by 5 is 10. And now we plug in our negative 10. This is negative 10 here. And then that's 1. And then negative 10 plus 10, and that becomes a 0. So there's nothing here. It's just negative 10 cosine. Okay, great. So now negative 10 is dx. Okay, good. So when you integrate, you will get your velocity function. Then you use the point given to compute the value for c. And that value for c in this case would be 0. And you have your velocity function. So I'm going to actually box velocity function, because that's one of the important equations here. So now if you tell me if you ask me, what happens with the object after 10 seconds? Well, I just put t equals 10. T equals 10. That's going to be 10 times 550. So that's cosine of 50 radians. And you calculate that in your calculator. You make sure you're in radians. And cosine of 50 and then times negative 10. And you have the velocity, whether it goes forward or backwards, right? Positive numbers go forward, negative number go backwards. And you can calculate velocity of this particle or whatever it's moving. Now, being that it's a motion like this, it's probably a particle moving. Then velocity is equal to change of position in time. We copy the same equation, obviously. And then we do our separation of variables, which gives us negative 10 cosine 5t and then dt. Integral of cosine is positive sign, so this becomes negative 2 sine 5t plus some c. And then we have that the x0 is equal to 8, so x at 0 is 8. 8 equals negative 2 sine of 0 plus c. And from there you get that c is 8, because sine of 0 is 0, and then 0 times negative 2 is 0. So that whole term dies, and c is 8. So position function x of t is given as negative 2 sine 5t plus 8. And this would be your position function. So you have acceleration function given in a problem. You have the velocity function you computed, and you use the point to calculate particular solution. And then again, did the same procedure again. By the way, this is your general solution right there. And then once you use the point, you came up with a particular solution at the end. And that is the position function for. So now, if you give me time, right, in seconds or whatever, I will be able to tell you where the object is. So acceleration will give you velocity and position, and you can know how fast the object is moving, and you can also know the position of the object as you go through. And that's it. So sine of 0 is 0, cosine of 0 is 1. And I think, yeah, I think that's it, guys. I hope you're not disappointed, but that's the today's stuff. If I are there any questions, concerns that you would like to address? And I was thinking of changing the format of the class a little bit. I'm planning on running Zoom parallel to this, so that you can also, ask questions live. So it will nothing changes. Your videos are still on YouTube. The lecture is still on YouTube. You can, if you want to, you can just run run Zoom in the background. So you can ask questions rather than typing, because obviously asking questions when you need to is faster than. Now, the little problem here is the delay. There is, I think, 10 or 15-second delay from when I write something until you see it. So it's not 100% real time, but we'll do the best we can, right? And yeah. I see the questions are the homework. So homework is on MyMATLAB, which is the platform you are purchasing. MyMATLAB will be assigning the homework. There will be due dates. And remember that I said the syllabus and the first day, minimum of 5 problems need to be done correctly, right? You can do as many problems as you want. You can go to study plan and get even more problems, and clearly your textbook has a whole bunch of problems. So there is, okay, 10 seconds. Okay, thank you. So I am going to open right now section 1.2 as well. And the next class is on Monday. Once I get the Zoom link, I will also post that in modules, and there will be an announcement. So when you log in, you can log in into Zoom for voice communication. So we don't care about cameras or anything like that. We just care about the voice, so that you can ask questions real time because it's faster than typing. You are still welcome to use chat because I will be. Please do not use Zoom chat because I can't monitor 2 chats and stream output and Zoom voice and then teach at the same time. So I am banning the Zoom chat. So you are using this chat here. Lecture on YouTube. You can see everything live. Keep in mind that when you ask a question, it will be instantaneous, but my answer will lag 10 seconds. So if you don't hear me answer in 5 seconds, don't immediately ask it again and again and again, right? I will hear it instantly, but then there will be a delay. Oh, this is going to be bad. Guys, I just realized that you're going to have 2 audio, because you will have Zoom giving you the instant audio, and you will have YouTube giving you a 10-second delay audio. Yeah, I gotta think about these things. Yeah, I'll solve these problems as we go. Right now, let's just have this way. Homework is due the 13th. That's correct. Are you opening today 1.2? Yes, I am. You can mute yourself on Zoom. I will definitely do that. Okay. Well, yeah. I will mute myself in Zoom, and then if I forget, you will just let me know that I forgot to mute myself. No, I will mute my Zoom because I want you to, when you are watching the YouTube, I need that sound, right, to be in sync with what I'm writing. So I will mute my Zoom. You will not be able to hear me through Zoom. You will hear me through YouTube. I will hear you through Zoom. So if you have a question, you unmute your button, your mic, and you ask a question. And then 10 seconds later, there will be an answer coming out of the YouTube video sound. That's okay. It's still better than typing, because it takes you time. It will take you much longer than 10 seconds to type everything and then for me to respond, than for you to just say something and then I can immediately hear it. And so you will ask the question instantly and then I will answer within 10 seconds. So yeah, better than typing, right? And I'm not sure, maybe there is a setting somewhere in YouTube. I'll have to check. Maybe the delay can be eliminated or even put down to 5 seconds or something. Delay is there for stream sniping, for you know. The Discord server. Okay, so yeah, I had this great idea to have a Discord server where you will collaborate and do the math, and then have a separate chats for trolling. Apparently, the math stuff never caught on, and trolling did. So when you go into the Discord server, there should be rooms that are only for math, and there shouldn't be any jokes in there. And then there should be other channels. I don't know. I haven't been there. Rari, I guess you are in charge of some of the stuff there. So yeah. Stream sniping was much worse for my for Counter-Strike than League of Legends. So yeah. Oh, then there has to be someone else's server, because the server that I had for Discord had 20, 30 rooms. Then that Discord is not. I don't know about that Discord. I remember that someone said, "Oh, I just created Discord server." I know someone said that, and that's not the one I created. So yeah. But you guys can also meet on Zoom. You guys can create your own groups. Those of you interested in creating groups, you can send emails. If you want to meet, go ahead. I will never discourage that. And you can't meet on campus, but the world is a little bit bigger than the campus. So there you go. And yeah, so think about stuff, and we'll be back on Monday with extra thing. Now, I posted also links for the office hours, and you see 3 different links because Zoom doesn't have an option of picking days and hours. So if you pick an hour, it has to be the same hour every day. So there are 3 different links for different days and times. So if you want to see me on office hours on Wednesdays, make sure you click the Wednesday office hour link to join the meeting. And that stuff is in announcements and also on your email. Any other questions, concerns? Shoot it in chat. And if not, I'm just gonna release you to have lunch. Listening? Solution to Zoom? To be honest, I thought we solved it. I just mute myself and that's it. Oh no, I tried that, and these school-issued tablets are the lowest spec tablets. They have very little RAM memory, and these awful Intel processors. So you really can't do a good job without AMD and Ryzen and all. Intel is garbage now in comparison to AMD. So the problem was that I tried to do that in algebra class, and recording a video while streaming and teaching and Zoom and everything else, that the 2 tabs that were open in Google Chrome, it was just impossible. It was really, really bad. So, and then also I had to upload manually. That was also another bad part. These lectures that I do right now, that's automatically uploaded as soon as I end the stream. Within 5 minutes to an hour, it's available. And I don't have to push even a button. It's all set to publish automatically when I'm done streaming. So, it's also less work for me, because I also have to deal with notes and everything else. So we'll try on Monday to run Zoom parallel to this stream, and then you just I will mute my mic on Zoom, and if you have question, you can just ask in Zoom, and I will answer it, and you will hear the answer obviously through the YouTube video. And you asking a question, that's another good thing, is you asking a question is not part of a Zoom. The other bad thing about Zoom is when you do the record video on Zoom, it includes your names and your cameras and everything, and that's another thing that it's not good for recording Zoom sessions. So all right. Is it possible to get added to my MATLAB if I had the previous access? Well, if you had the previous access for differential equations, and let's say you withdraw from the course for whatever reason or whatever, only if you had the multi-semester license. When you are purchasing my MATLAB, you are asked for one semester access or multi-semester access. If you purchased one semester access and you used it up already, then they will ask you to pay again. That's the way I understood the way they're set up. So check what license you have, but I mean, technically, if you go to my MATLAB now and type in my course ID, if you are in the course, that's it, you're done. If they're asking you to pay, then the previous access is no longer valid, and you would have to purchase a license again. Now, I think they have a one semester license and then multi-semester license, or for life license as well, meaning for the life of the book. So yeah, that takes care of that. Anything else? Well, if there is nothing else, I will see you all on Monday. If you need me during office hours, I will be there. Oh, Saturday office hours for this week only are canceled. I will put the announcement regarding that. I have some volunteer stuff that I'm doing with Rotary and collecting money for food and veterans and so on. So it's a fundraiser, which you can actually participate on. Your participation would be on Sunday. I have Saturday and Sunday stuff to do. So Saturday office hours are canceled, but everything else will be going on. If you're interested, just shoot me an email, and then we can meet. All right, guys. See you later. Bye.